Okay, what we're going to do in this video is go over this worksheet here. This is all about path difference, and we've got this lovely diagram here which contains the ripples from two source points. Okay, so we've got source point 1 and source point 2. Now what we might imagine is that source point 1 and 2, they might be speakers, or they could be small objects in water that are vibrating up and down. And what we can see are the wave ripples, essentially, that are emanating from each of these 2 points. The line thicknesses relate to this key here. So this key shows that any thick lines are crests and the thin lines are troughs. Now what we are doing when we work out path difference is we're working out how close we are to each source point, and then working out the difference between the points as such. And now what I did in class is I talked you guys through, if we calculate point C, so C is the point I would probably start with because it is closest to source 1. You can actually then work out exactly what's going on in this particular image. Now what we need to think about is actually, to start with, source 1 is actually at the bottom of a trough. Okay, so let's just draw an image of this. So source 1 as a point is going to be at the bottom of a wave that looks like that, and this thick line just here is the crest. So that is the thick line, and then we come to point C. So that's point C there. Okay, and what we can see is that this distance, that entire distance, is 1 lambda. Okay, now you can do it one of 2 ways. You can either count from the point to the first thin line, so that's 1, or if you're struggling with that and you're just having to count the lines that are there, you can actually count 1, 2. Now what that essentially means, you've counted 2 lines. You've counted a thick line and then a thin line, and then what we're going to do is we're going to half that. So either way, 2 divided by 2 is 1. Okay, so the distance here is 1 lambda. Okay, so that's that distance there. Now we want to work out the distance between S2 and C. Now if we would draw the image of this, it would go on and on and on. We haven't got enough space up here to show this, but what we need to realise is source 2 is also at the bottom of a wave. It's a trough. So we're going to count to see how many lines we are. Now I'm going to do it the way where I'm going to count the lines, and I'm going to half it, and then that will tell me the number of wavelengths. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and I'm on that line there with the C. So that's 7 lines, so therefore half of 7 is 3.5 wavelengths. Okay, and we can do this again if you prefer. So counting the thin line, so if we go from source 2 to the first thin line, that's 1 thin line, 2 thin lines, 3 thin lines, and then half a line, which gives us the 3.5. Now all we're doing now is we're doing 3.5 minus 1 gives us 2.5 lambda. Okay, and that is our path difference from there to there. I mean, obviously we're closer to source 1 than we are from source 2. Now the other thing that we can note is that point C is on a thin line and a thick line. And what this tells us is it's on a crest and a trough. If we get a crest and a trough, we can actually think about the interference. In this particular case, if we have a crest and a trough, we will have destructive interference taking place, and those waves will be cancelling up each other out. Let's do another one. Now I'm going to pick point M. M down here is closer to source 2, and again we can count either the number of lines, so we go 1, 2, so therefore it's 1 wavelength, because 1 is half a wavelength and 2 is a full wavelength. Okay, so 1 lambda, and then from this point to M is going to be 1, 2, 3, 4, 5, 6, 7. Very similar to the one that we just had up here, but obviously it's closer to source 2 this time than source 1. So our path difference is 2.5 lambda. Okay, next closest, let's do J. So J is here. So let's go from source 1. Source 1, we're going to go 1, 2, 3, 4, 5, 6. So that's half of 6. So that gives us 3 lambda. 3 lambda from there to there. Then we're going to do source 2. We're going to go 1, 2, 3, 4. So that's 4 lines, which half of that is going to be 2 lambda. And again, so it's slightly closer to source 2 than it is to source 1. And we have a path difference of 1 lambda. Now bear in mind again, we haven't filled in this column for either of these two, so let's go back to point M. Point M is on a thick line and a thin line, so therefore is destructive. Point J, if we look carefully, is on a thin line and a thin line. Now what that will mean is it's on a trough and a trough. Those troughs will add up to make constructive interference. Okay, next point. Point D. Point D is, so there we go, 1, 2, 3, 4, 5 from S1. So half of 5 is 2.5 lambda, 2.5 wavelengths. And from point 2, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Half of 9, 4.5 lambda. So that is a 2 lambda path difference. Okay, next closest, let's go for K. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, K is going to be 4.5 lambda. And then we have 1, 2, 3, 4, 5, 6, 7. Half of 7, that's 3.5 lambda. So the difference here is that. And again, I'm not going to fill in all of this. I'm going to do a fair few of them just to start to get you, make sure you're getting your head around this. Let's do G. G is 1, 2, 3, 4, 5, 6, 7, 8. So that's 4 lambda. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 4.5 lambda. So that's 0.5 lambda difference. And then let's do H. So H is interesting because H is right on this middle line. If we use a pen, we can actually line up H with that center point. So actually we should expect to find that H is the same distance from S1 to S2. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So half of 14 for H is going to give us 7 lambda. And we should find the same in this distance here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 7 lambda, and there is a 0 lambda difference. Now what we should start to notice, anything on this line, I'm going to do this actually in a red pen. Okay, so the red pen is going to be, I should probably use a ruler really, but you can do this. Anything that sits on that line there is going to have a path difference of 0, okay? So that's H, so you can see that there, 0. So that's going to have a path difference of 0 lambda. Now what we notice with G just here, and G is interesting because G actually sits with F. I'm going to do this with a green pen. They're in a similar line here, and what you'll notice is if we draw a line through these two, they will have a path difference of 0.5. I on this side is going to be very similar again. So again, if we draw a line like this, that's going to be 0.5 lambda. And you can count this and you can check it. It will be the same. Now what we can then do is we can do the next set. So have we got any with 1? Yeah, J and K. Now J and K again are on a line. They're on a pattern line there. These have a path difference of 1 lambda. Much the same as point E. So again, 1 lambda there. So you'll find the answer to that, to E, will actually be 1 lambda. and I can tell K and J. We already know those, okay? And what we'll actually find is there's a definite pattern to the way that these points are beginning to form on the page. What we'll find next is L. L is on the next line, so I'm going to get a green pen on this one. So L gives us our next line, and what you might notice is you've got 0, 0.5, 1, so this is going to be 1.5 lambda. So L, the answer there is 1.5, and I've done that without having to actually work this out. I'm just working this out by using the patterns here that we can see. D, we can see D is 2. Again, D and B are on the same line there. You can stretch that one out to there. And then A and C are on a similar line again, like so. So C has a value of 2.5. We can predict there that A is going to have that value just there. M and N are very similar again, and they shoot out like that. It's just slightly missed the line, but don't worry too much. M we know is 2.5 lambda as well, so N is on the same line, but it has a 2.5 lambda as well. Okay, so let's just fill in the gaps here. So F is 0.5 lambda, I is 0.5 lambda, and B is the same as D, which is 2 lambda. So those are your answers the way down through here. You can fill in these gaps. All you need to do for the points is just look at whether it's on a thick or a thin line. So what you'll probably find, actually there's a pattern to this as well. So H, as you can see, H on 0 lambda is on a thick and a thin. And what you'll find is that a 0 lambda is constructive. What you'll find at 0.5 is that you'll have a thick and a thin line on every single one. And this tells us that it's destructive. And then you'll find the next ones, the 1 lambda ones, will all be constructive. And you can probably see that there's a pattern building up here. C, D, C, D, C, D. So the next one's going to be D, and the next one C, and the next one D. And you see how that pattern is building up. And what this actually relates to then is anything on that D line is where we're going to have flat water, if this is on water, and you're going to have that destructive pattern. And here is the C. This is where you have the ripples that are larger. If you think back to your ripple tank experiment, we could see these patterns, and if you remember back to that, and there's a simulation on the website that also allows you to visualize this. You can see these distinct lines where there is destructive patterns going on. I'm hoping that helps you to work through that one. If not, drop me an email. I'm happy to talk you through it again. So hopefully that makes sense. Thank you very much.